Yeah, morning all. So yes, so in this today's session we had some introduction related to PySpark, right? Spark is the this lightning fast technology that is designed for fast computation, right? Apache Spark is designed for fast computation. It is one of the demanding tool among the data engineers to work with the bigger data sets. So Spark, it is an open source. It's not licensed. It is an open source. Can see, okay, you can download Spark even if you want to install it in your local machine, right? Can just download it from Apache Mirror's website. Apache Mirror's website, it is an open source. It's a distributed cluster computing framework. Distributed cluster computing framework means, yes. So here the Spark data is going to get distributed across multiple systems and processed by multiple systems. That's what we call like parallel process style, with in-memory computation, storage, and processing both happening within the memory level, within the RAM level, right? Yes. Used for large-scale data processing. Used for large-scale data processing. See, one thing before I go, you need to understand, right? Here, it doesn't follow like client-server architecture, master-slave architecture. See, single master, multiple slaves. Single master and multiple slaves, right? So this master node, driver node we say. Master node or driver node. Understand here? Right. Srinath, yesterday we had some introductory session, right? Yes. Master node or driver node. This we call it as slave nodes or worker nodes. S1, slave 1, slave 2, slave 3, so on up to slave n. Slave nodes, or we say like worker nodes. Worker nodes means master node, this entire thing we call it like a cluster. Driver node will only one master and multiple slaves, single master and multiple slaves, master slave architecture. So here one driver and remaining all we call it as worker nodes or slave nodes. If you got any data, for example, if a big data object, for example, f1.txt, a file like TBs of data, you got like TBs of data, right? That data will be divided into smaller parts. That data is going to be divided into smaller parts. Means think that like 3 TB data. Data is going to be divided into smaller partitions, we say, that are going to be stored across multiple systems. That are going to store across multiple systems and processed by multiple systems parallelly. Distributed storage you can see, and parallel processing you can see. Distributed, and that too, it's going to be stored within the RAM level storage and RAM level processing. RAM level processing will be very fast processing, right, as compared to disk level processing. So that's the reason, right? Here, distributed execution framework with parallel processor style, with in memory, within the memory level storage, within the memory level processing, used for large scale data processing. See, Apache Spark, it's a execution model, it's a processing model, can be coded using Python language, Scala language, Java language, and R language. Mostly used is Python and Scala. Python and Scala language are the mostly used languages for implementing Apache Spark. The general engine, I can say Spark is a general engine for big data analysis, processing, and computation. So why PySpark means? Yes, it is a Python API to use a Spark. Python API to use a Spark. PySpark is used for running distributed SQL, creating a data pipelines, ingesting data into database, running ML algorithms, working with graph algorithms, working with streaming. Spark is 100 times faster than normal disk processing. Spark is faster than normal disk processing. Yes, I was saying one example, right? Yeah, I was taken a table of 100 TB consisting of 1024 columns. Task was sorting based on 16 columns. Time taken by different databases like Oracle taken 3.5 days. MySQL has taken 6 days. Teradata has taken 4.5 hours. Netija has taken 3 hours. Hadoop finally has taken minutes of time. Hadoop has taken just minutes of time, right? Yes. So yes, Hadoop speed, you can see compare the Hadoop speed with the other things, right? Other things. So it has got very high speed, it has got very high speed. One second. Yes. Spark is 100 times faster than Hadoop. See, already Hadoop speed is very fast. It has taken minutes where it has taken days and hours of time. Spark is 100 times faster than, check the speed of Spark as compared with that. So, yes. So need for PySpark means today like huge data is getting, why we need to go for PySpark? Why we need to go for this kind of Spark technology means large amount of data is getting generated everywhere. Huge data is getting generated everywhere. So from that huge data, from that raw data, if you want to extract some useful information, otherwise some business informations, if you want to extract from that, so like the data might be containing some hidden patterns, unknown corrections, market trends, customer. Yes, another useful information. So we need to extract some valuable informations from this raw data, from the huge data. We go with the tools like Spark, the tool by Spark, right? So previously we have got some tools, but the tools are not, means they cannot handle huge data. So we need to have some scalable and flexible tools to crack this big data and gaining benefit from it. So PySpark is such a kind, right? So combining Python and Spark will be the very efficient for the world of big data. So that's why Apache Spark community came up with a tool called PySpark. So the main features of PySpark in-memory computation means storing within the RAM level and processing within the RAM level, right? In-memory means memory level storage and memory level processing. So that because of which we got very high speed. Lazy evolution. Lazy evolution means on demand, means when required only we will be executing the data whenever required, whenever you want, what point of time you want to execute, you can execute, right? The data flow. Persistence means one more feature of PySpark. Already executed transformation output, you can reuse it. Already executed transformation output, right? You can make use of it. No need to again re-execute. Partitioning means, yes, Spark data object, Spark data is going to be partitioned into partitions, right? And those partitions are distributed across multiple systems. processed by multiple systems parallelly. Powerful fault tolerant model. Powerful fault tolerant model. Spark has got a powerful fault tolerant model. Means your data is running on multiple systems as they are systems machines, right? So there is a chance of any machine going down. Then in that machine, the particular data partition which is stored will be lost. So Spark has got the capability of regaining the lost partition that I later I'll discuss in brief. An evolution of Spark I was discussing, it was introduced in the year 2009. It was open sourced in the year 2010. It was donated to Apache Software Foundation in the year 2013. So yes, execution generations, right? So we have got Tej and Spark. Both are directed as cyclic graph model. Tej doesn't follow in-memory computation, but Spark. Tej doesn't follow in memory, but Spark follows in memory. So Spark has got high speed over Tej. Other in-memory computing systems, HANA, the SAP HANA, right? SAP HANA is also a in-memory computing system like Spark. But HANA is not distributed. Data is not distributed, but Spark is a distributed RAM. So Spark mainly designed for batch applications. Batch applications means which involves millions and trillions of records. Not for online applications, not for client server, not for request response. It's for batch applications. Iterative algorithms. Iterative algorithms means generally we talk about mainly this data analytics related algorithms, ML algorithms, right? Whenever you apply any algorithm on the data, you get some errors. Exactly, it cannot predict the things. So like predictive algorithms, if you take, it won't predict the things exactly. There may be some error. Again, you are going to arrange that coefficient. You are just going to arrange the coefficient, right? And again, you will apply it. Again, the error will be little less as compared to the previous one. See, very simple, right? Iterative algorithms. For example, a labor example. Predicting the age. For example, your age is 30. I'm asking to predict your age. You are saying your prediction was 40. There is some error, right? Again, I'm asking you to predict. This time your prediction was 35. Again, error. Again, I'm asking you to predict. You are predicting as 32. Finally, you are saying it as 30. Now there is a match occurred after n number of trials. After multiple iterations, right, you are able to say that correctly. The same way here also, for example, one more labor example. A tree, it has got some fruits. For example, you are supposed to hit the target, the fruit, with a stone. First time when you hit, it went somewhere in this way, in this direction. So next time what you will do, you will adjust the things, you will adjust the things so that the target, it will go little near to the target. So in this way, after multiple trials, you are able to hit this fruit on the tree. Means every time you are adjusting yourself so that you are reaching near to the target. The same way here, if you are any type of algorithms you are applying on the data, first time the prediction will be, means the error will be more. Again, if you keep on adjusting the coefficient, again, if you are able to apply that algorithm on the same data again and again, until the error becomes a 0, you are able to predict it. The same way, most of the algorithms will be iterative algorithms where will be Spark is mainly designed for those kind of algorithms, for interactive queries like SQL queries, and for streaming data. Streaming data, right? Data which keeps on generating, data which keeps on incrementing, such kind of data, right? Spark mainly deals with. Yes.
So here, streaming means continuous flowing, right?
If I talk on this streaming, 1 second.
Mhm.
See, for example, static data and streaming data. If we talk about this static data and streaming data. A labor example, if we see the labor example. See, for example, you downloaded a file from your website. For example, think that a movie file, .mp4, MP4 format. That size is like a 2 GB file. 2 GB file you have downloaded, right? So if you talk morning, you have downloaded it. Its size is 2 GB. Afternoon, if you see also, it will be like 2 GB. Evening, if you see, it will be like 2 GB. There is no change in the size of that file. After 2 days, if you see, it will be the size 2 GB of this. After 10 days also, it will 2 GB. But streaming data, if you take example like your webcam or CCTV or webcam, right? Yes. Morning, okay, if you are seeing like 2 GB. Afternoon, you won't see the same size, right? Goes like 4 GB. Evening, you see like 6 GB. After 2 days, like 10 GB. After 1 week, like 20 GB. Means data which keeps on incrementing, data which keeps on generating, data keeps on generating. Okay, such data we call it like, means the events keeps on generating, data keeps on generating. Such kind of data we call like streaming the data. Okay. So most of the time, see, if you see in the industry, data streams, we say streaming data. At a very high rate of speed, the events are generating. One second. What do you mean by the events means? Okay. For example, data is generating. Events means nothing but data is generating, right? For example, uh, for every 1 second, events generating means for every 1 second, some 2000 lines of data. For example, some 200 or 2000 lines of data is generated for every 1 second, for every 10 seconds, you say otherwise. 2000 lines of data for every 10 seconds, for every 10 seconds, for every 10 seconds. Means data is keeps on generating. Today, if you see, the industry is expecting a quick results or quick updates. We want a quick updates, means whenever 1 minute, in 1 minute, how much data is generated? For every 10 seconds, 2000 means for 60 seconds, how much? 2000 into 12, like in this way. Huge data is generated means whenever that 1 minute data, for 5 minutes, how much? For 1 hour, how much? So this data is keeps on generating, means at a very high rate of speed, this data is generating. For example, for every 10 seconds, 1 lakh lines of data is getting generated. For 1 lakh transactions are happening. For example, for every 10 seconds, 1 lakh transactions means 10 lakh, 1 lakh transactions means the transaction that whatever transaction ID, the transaction name, product ID, cost, whatever that is, transaction details or whatever the data details, right? Means for every 10 minutes, if you see some huge data is getting generated at a high rate of speed, at the same rate of speed, the data has to be processed and the results has to be. You need to see the results of it. Means yes, yes, I'm going to cover it. Yes, Srinath, right? Yes. See, for every 10 minutes, at what rate of speed the data is getting generated, at the same rate of speed, we require a technology. Which should process it in the same rate of speed. So Spark is a kind of technology where it can process the data at a very high rate of speed. If huge data is getting generated for every 1 minute, like lakhs of records are generating, lakhs of data is records are generating, right? So in the same rate of speed, the data has to be processed and we need to get the results. So here, so that's what I was saying for streaming and for batch applications and for micro batch applications, right? Spark is mainly designed. So yes, so here I was talking, okay, where exactly this PySpark used means most of the time in the commercial sector, in financial and in banking area, right, where Spark is used for retrieving the customer's social media profile, analyzing and gaining useful insights from it, and taking the right decisions. And even in this e-commerce and trading, right, like websites like Flipkart or Amazon, they use Apache Spark for advertising, right? And even the popular OTT platform like Netflix using Apache Spark for real-time processing. And it is approximately like it is processing 450 billion events per day. And even in the healthcare, in identifying, predicting the patients who are going to face that issue, and many other fields, right, in the tourism industry, in other things. So yes, I'll be discussing about yes. I was just briefing you about PySpark in the last. Just I'll be providing mm, DataBricks. What is DataBricks? Today I'll be just briefing you about a DataBricks. What is DataBricks? Generally, what is DataBricks, and what DataBricks is going to provide us? Okay, Spark, Spark. Two main features of Spark. Two main features of Spark, right? Yes. Before I come to the DataBricks, two main features of Spark. Hmm. One is in-memory computation. In-memory computation, because of which with very high speed you are going to achieve in-memory computation, right? Memory level storage and memory level processing, right? Secondly, massive MPP. MPP, I'm saying. MPP. What do you mean by MPP? Massive parallel process. Massive parallel process. Spark, it is a processing model which processes huge data, big data with a very high rate of speed. So, but here the, okay, problem with Spark. Independently, it cannot run. It needs a cluster. It needs a cluster, right? Like master, just now I was talking about driver and worker nodes in this way. It requires a cluster. Uh, driver node and slave nodes are worker nodes. It requires this. Means your data will be distributed across multiple workers, and data is processed by multiple workers parallelly. So it requires a cluster. Who provides this cluster? DataBricks. So who provides this cluster? DataBricks. DataBricks provides Spark cluster in the cloud. Example. Assume you have, for example, assume you have some 400 nodes. Systems, nodes means systems. Assume that you have got 400 nodes and 400 systems. Now, these 400 nodes for systems worthy processing 2 TB data. Assume that it is worthy processing 2 TB data. See, just now I was talking about master and slave, that is a driver and the worker nodes. So here, if you got some 400 nodes, is worthy processing 2 TB data at a time. For example, okay, tomorrow your data volume increased. Tomorrow your data volume increased. If same cluster is used, speed goes down as data volume increased. So we need to scale up. We need to scale up. We need to scale up the cluster by adding some additional nodes. By adding new nodes. 100 nodes, think that 100 nodes added. 100 nodes added. We need to scale up the cluster. Okay. So we need to scale up the cluster by adding new nodes. That is 100 nodes added. 100 nodes added. Again, whenever data is increasing, again data is increasing. Again after 2 months. Again after 2 months, right? Again 100 nodes added. But every time scaling up. Physical data center is a complex task. So that's why I need the same cluster. I need the same cluster in cloud. And that too, what features I'm expecting. So that's why I need the same cluster in the cloud, and that too with auto scaling, capability, with auto scaling capability. So who is providing this? Who is providing this? Databricks. So it is providing Spark Cloud Cluster. Spark Cloud Cluster with auto scaling feature. Databricks is providing this, right? Spark Cloud Cluster with auto scaling feature. Auto scaling, okay, 1 second. One more example, check it for today. My data load requires 150 nodes. For my data load, it requires 150 nodes. Okay, today, okay, but fine.
What is this node, sir?
Systems.
You mean
See,
slave nodes?
here, yes. 1 second, slave nodes. So this one, worker nodes or slave nodes.
Hmm.
So where your data is going to be stored across the multiple systems, right? So huge data, we are talking about huge data, right? Petabytes of data. So where your data is divided into partitions stored across multiple systems, multiple nodes, we say. So today my load requires 150 nodes. That is my data load requires 150 nodes. For example, tomorrow, data volume increased. Data volume increased. It is increased or extended to 200 automatically. So it is increased or extended to 200 automatically. Again after processing, after processing is completed, again processing is completed. $150 nodes. How much it is increased? Again, after the processing is completed, again it has to revert back to 150 nodes. So auto scaling feature means whenever the data volume is increasing, automatically it has to scale, it has to increase the number of nodes, right? It by itself. That is auto scaling feature. This is general Databricks. This is general Databricks, right? What I'm talking is general Databricks. So generally, so as I said, we are going to use as part of this course, I'm going to discuss with Azure Databricks. The cloud we are using is Azure Cloud. I'm talking about Azure Databricks. Yes, we can create our, yes, Srinath, right? We can create our own cluster. Yes, we can, but manually doing all these things is a, see, every time scaling up the physical data center is a very complex task, right? We can create our own cluster, but automatically, that's what I'm going to say in Azure Databricks, how it is going to.
Okay, but how it will decide whether it should increase the number of nodes or not?
See, that's what, if today my data load is this, I require this many nodes, okay, this many nodes. So, but tomorrow, like data volume has increased, huge volumes of data, incoming data, right? So
Okay,
automatically it has to increase, extend to up to 200 automatically. So we will be providing the range. See, whenever you are creating a cluster, you will be providing a range. Okay, minimum this much, maximum this much.
okay, good.
You will be providing the minimum 10 to, okay, 500 or 50 to 500, minimum 50 to 5. In this way, automatically it has to, whenever the data income based on the incoming data, it is going to scale up.
Okay. I mean, before processing the data, first it will check the size of the data, right? First initial.
See, generally when we are creating a cluster, right, with n
Mhm.
number of systems, right, will be providing the range from where to where. What is the max range of the systems? What is the min range of the systems? So how many are processing the data? How many slaves required? That many it takes generally. But tomorrow, like if data is increased, like double the data if you are getting, right? So it automatically it has to scale by itself. So that is a general, I'm talking, this is general DATABRICS. This is general DATABRICS. But generally, you will be taking the input, you will be taking the input from some storage area, right? And finally, you are going to the processed results. Again, you are going to write into some target system, right? See, generally, from where you are taking the input from, you are taking the huge data from where you are taking. What is the input source and what is that output target? What is the output target from where you want from where? So here, if you talk about in Azure, we have got, if you have got an Azure, we have got some storages available like Azure Data Lake, Azure SQL, like Azure Cosmos DB, right? Yes. So here, this is general Databricks. This general Databricks, it cannot interact. It cannot interact. General Databricks, it cannot interact with Azure Storage Services. Azure Storage Services. General data, it cannot interact with the Azure Storage Services. So what are the Azure Storage Services available? Azure Storage Services. If you want the data in the structured in a tabular format, we have got Azure SQL. We want the data in the form of files. Azure Data Lake is there. If you want in NoSQL, like Azure Cosmos DB. Just like NoSQL, just like MongoDB, we have got Cosmos DB in the Azure. Like data lake for file system, for table storing in the form of table, we got Azure SQL. So this general Databricks cannot interact with this kind of storage services. So regular Databricks. Regular Databricks is not compatible. So that's why if Microsoft and Databricks. That's why Microsoft and Databricks. They launched a new product called Azure Databricks. Launched a new product called Azure Databricks. Now, what is Azure Databricks? Azure Databricks, right? It is a Spark cluster with auto scaling. Spark cluster with auto scaling and compatible. Try to understand. So Spark to execute it require a cluster. Cluster means group of systems, means huge data is going to be divided into smaller partitions and distributed across multiple systems and processing. So who is going to provide that cluster? Databricks. Databricks, okay, it is providing the cluster, but for reading and writing, right, it has to interact with that Azure storages. But for that, for interacting and compatible with that Azure storage services, Microsoft and Databricks collaboratively, they launched a new product called Azure Databricks. So it is a Spark cluster with auto scaling and compatible with all the Azure data storage services. Azure data storage services. Azure Databricks. Now, Azure Databricks ADB, right, can read data from Azure SQL, like if you want like table from data lake, from Azure data lake, like file system, and Azure Cosmos DB for NoSQL, right? Azure Cosmos DB, right? Yes. Mhm. So normal Databricks also, we cannot say for normal Databricks also, we need to provide some kind of other settings. For normal Databricks, lot of other settings, lot of we need to do lot of other settings. We need to call different APIs. We need to call different APIs. See, Databricks is not only available for this Azure, Databricks also available for AWS and for Google. Databricks is also available for this AWS Google. So how many nodes you need in a Databricks cluster based on the, yes, based upon the data volume, right? You are going to decide how much cluster. So you have the control, you have got the entire control on this cluster in this data Azure Databricks, right? In this, you'll have the entire control in the cluster because you are going to create, you are going to design the cluster. We have got different types of clusters available. Later I discuss about this. Okay.
Sir, here I have one like you said like under the work node have under the driver node have so many cluster worker nodes, right?
Mm.
Yeah. For example, we have 200 worker nodes. Uh, driver node where we can choose under the
See, one thing, what do you see? Group of nodes, group of systems connected in a network. Group of nodes interconnected. See, one is the driver node, master node, and remaining all will be the worker node. The driver node is the main node, is going to take care about it. It will have the entire control about all the other worker nodes, slave nodes. And who is going to provide the logic? See, who is going to provide the logic? For example, with what? For example, you have got your data distributed across multiple worker nodes. Check with this diagram. See, this is one worker node, 1, 2, 3, 4. In this way, hundreds of nodes are there. For example, each worker node has got some data, some GBs of data. Assume that some data is available. But with what logic the data has to be processed? Parallel processing has to happen in all this, right? Who provides the logic? Driver load provides the logic, business logic to all these worker nodes. With that logic only, they are going to get executed. With that logic only, they are going to get executed. See, one second, if you see this Spark architecture, right? Later I discuss in brief. It is too early to discuss, right? One second. This is your driver. Assume these are your workers. These are your workers. This is your data. Assume this is your data. This data is divided into multiple partitions. Multiple partitions. P1, P2, P3, P4. Data is divided into multiple partitions, hundreds of partitions. Assume this is your slave 1, slave 2, slave 3, slave 4, slave 5. Okay. Here P1 is the partition, P2 partition, P3 partition, P4 partition, P5 partition. Means data is divided into partitions stored across multiple systems. Okay, who should execute these partitions? Who should execute these partitions? Okay, slaves only, they are going to execute, but see, with what logic this P1 partition, P1 I think that there's some 10 lakh records in this, there are some 10 lakh records in this, 10 lakh records. With what logic they have to be executed? Who provides that? Driver provides it. Driver provides the logic to each and every partition. Driver provides the logic to each and every slave, that is worker node. And there is one more process. There is one more internal process. See, this is logic. It is providing logic. It is providing logic. It is providing logic. Execution of this partition plus logic is taken care by another process called as executor. Understand carefully. Execution of this partition data along with the logic provided is taken care by another process called as executor. For this also, executor 2. Logic in this the partition, executor 3. Logic in this by executor 4. Logic and by this partition by executor 5. Means number of executors required. Means how many executors required depends upon your data is divided into how many partitions. If number of partitions, assume that 20 partitions, 20 executors required. 20 executors required. If 40 means 40 executors. See here, your task is what? Processing this partition along with the logic. So can I say number of tasks equal to number of executors equal to number of partitions. Can I say like this? So how many number of tasks depends on number of partitions. That depends on number of executors. How many partitions? Those many executors, those many tasks. So in Spark, the number of tasks equal to the number of partitions, that is equal to number of executors. So later I discuss all this in brief. Okay, just I'm saying how exactly this data processing is happening within this Spark. Okay, and we have got some inbuilt transformations and actions. We don't need to write huge codings here. We have got many inbuilt. We have got the concept of data frames, where the data is going to be made structured, and we can perform many inbuilt transformations and actions to be fine. You can just check with this. Okay, Azure Databricks with PySpark. So just I'll be providing some knowledge on this big data Hadoop, means how this before I go with the actual things, and Spark. Introduction to this Azure Databricks service, creating Databricks workspace, Databricks cluster creations, adding users in groups, how to add a user and how to add groups to the workspace, creating a cluster, and getting started with the notebooks. We are going to create with notebooks here, right? And jobs, Azure Databricks, displaying the clusters, what are the different clusters available, how to start a cluster, how to stop a cluster, how to terminate a cluster, how to delete a cluster, cluster logs, cluster access control, different types of clusters, right? All purpose cluster is there, job cluster is there, and Databricks pools with pools, without pools. Yeah. Auto scaling feature, Databricks runtime versions. What is the version of the Databricks? Multi-user clusters, single user cluster, credential, Databricks utilities, notebook utilities, secrets, job, file system, data, widgets, integration with the Azure data storage, Azure SQL, how do we can integrate with these things. And the PySpark data frame, if you see about this PySpark, that Spark processing, right? How to create a data frame, empty data frame from an RTD, from row class, column class, select, collect with column, all the functions, each and every function of this data frame, and PySpark SQL functions, window functions, data and timestamp, JSON functions, read and writing, built-in functions, each and every built-in functions with multiple working examples, handling multiple file formats, CSV file, JSON file, Parquet, Excel, XML, ORC, Avro files, DATABRICS batch processing, historical data load, incremental load, date transformations, aggregations, chain operation, union operations, external sources, working with SQL statements, transformations, narrow and wide transformations, adding of new columns, dropping of columns, renaming of columns, adding of new rows, dropping, handling nulls, window writing, database, streaming API, Lakehouse platform, Delta Lake, connection to Delta Lake, features of Delta Lake, how to create, how to perform DML operations, SCD type 1, type 2, data deduplications, workflows, connection to workflows, creating and managing Databricks workflows, full Databricks jobs, monitoring these jobs, right? Yes. Yes. Yes, you can just check this. There is a message given by this online team. You can check this contact details of them, the course content. If you didn't attend yesterday session, you can check with this, right? Demo videos, right? And the contact details and the payment details they have provided, check with this. And the prerequisites, I said, like basic Python knowledge is required, right? So basic Python knowledge. So just I'll be just show you practically some of this Python syntaxes, and also DURGASOFT, it is going to provide basic Python videos, right? You can just to go through that videos. Yeah, because bus trust, the Spark architecture and these things, Databricks I'll be discussing before we go with the actual PySpark, right? Meanwhile, you can see that Python videos that is given by DURGASOFT, they'll be forwarding you once you get enrolled, right? Tomorrow also you can attend the session, same timing at 8 o'clock, using the same link to see more discussion on this. I'll be discussing about this, how this computation is going to happen, the basic data objects, Spark data objects. Yes. So you'll be getting the session video of each and everything. Once you get enrolled, you'll be getting the video to your Google Drive, notes to your mail IDs, and a WhatsApp group will be created. You'll be added to the WhatsApp group. Yes. Any other queries from your side, anyone? So the cloud we are using is Azure cloud here. So the course content is shared in that by that. So you can see that DurgaSoft online team, they have forwarded the course content details and the payment details. A big message is given by them, their contact details, everything they have kept. Yes, you can just copy that entire big message, right? Tomorrow also you can attend to see more discussion on this, how we are going to deal with this.
Sir, does partition and slave nodes both are same or different, sir?
Partition.
Slave node.
See, within the slave nodes, right, systems, the partitions, data partitions are going to be stored. Data partitions means, for example, if the partitions, you mean to say the number of partitions, number of slaves means, slaves can be, for example, you've got some 300 slave systems, nodes we say, but your partitions are only 100. They'll be stored on 100 systems. Doesn't mean that your partitions or systems has to be, you've got 300 systems, but your data divided into 100 partitions. They are stored across 100 systems. It doesn't mean that your partitions and slaves should be equal. No.
So in one slave, there will be more than one node partition, right?
Yes. I'll just see this diagram, right? For example, if we take a small day, 1 second. Think that, okay, you got less number of systems. Think that you got less number of systems. 3 systems are there. Think that your data is, this is your data divided into 6 partitions. P1, P2, P3, P4, P5, and P6. Small data I've taken. Only 3 systems are available, S1, S2, S3. Means how these partitions will be stored, P1, P2, P3. Means again, P4, P5, P6.
Okay.
Means, for example, 18 partitions are there. 18 partitions are there. Only 3 systems are there. Here 6 is stored, 6 partitions, here 6 partitions, here 6 partitions, right?
So these partitions are happening on the driver node level or cluster level?
Cluster level. So here, what all the partitions are there? The partitions are going to be distributed across the system, slave systems.
Okay. So first the requirement is coming, the requirement we are dividing into partitions. Those partitions we are going to store in the machines, which means systems.
Yes.
Okay, sir. Thank you.
If you got more systems, more parallelism you will be seeing. But here, if you see 2 partitions, the system 1 first executes this P1, next executes this P4. Means this will be in the waiting state, right?
Mm-hmm.
This is executing, this will be in the waiting. Once this P1 done, next P4 will be executed. Means if you got more systems, means if you got 6 systems, 6 partitions, parallelly all the tasks will be executed parallelly. Nothing will be in the waiting state. That's why if more number of systems, more speed you can see, right? But if you are storing multiple partitions, right, in a single system, like some will be in the waiting state.
Okay, sir. Got it.
Okay. Fine. You can just go to the course content, everyone. Tomorrow, same time at 8 o'clock, using the same link, you can attend it. We'll see more discussion on it, right? Fine.
Sir, where will you be doing the hands-on? Which
So
platform?
yes, everything in Azure cloud platform, I'll be showing you, right? You can do it parallelly, right? How to get the software, everything I'll be briefing you, right?
Okay.
Databricks, how to install it, how to download it, right? So, but this is a very high-end technology, PySpark and this Databricks, right? So in the free, you won't get all the features. So you need to go with pay as you go, but with a very less cost. How we can do it? Once you practice, you are supposed to delete it. Once again, for recreating it, it hardly takes 2 minutes. So that's why, otherwise a lot of charges will be applied for it. So I'll be just discussing all those things during our practical sessions. What I recommend you people is do the practicals along with me parallelly. Right? Fine.
Okay.
So that whatever queries, anything immediately during the session itself, you can clarify those things. Means a lot of configurations will be doing, right? Sajid, right? Yes. Databricks and this PySpark is the main hot cake of this data engineering, right? So with this, you can just go to that job process.
Vijay, I have one question.
Yes.
So, Vijay, the data is automatically partitioned based on the nodes?
See how many nodes, if the sufficient nodes are available, in that nodes it will. If the nodes are not available, again the partitions will be, means just now I said how they are going to get distributed. In a single system, again multiple partitions will be stored.
It is automatically done.
Means yes, this whatever this is partitioning happening, everything taken by the Spark framework only. You no need to do anything for that. So if you want to increase the number of partitions, you can increase the number of partitions. We have got that option. Means if you have got more systems, I want to increase the more partitions. But automatically the Spark is going to take care about all these partitions, dividing the data and storing everything. Spark is going to take care. You don't need to do all this.
How to decide the number of nodes based on the partitions?
Not based on the partitions, right? Okay, how many nodes you want, depending upon the incoming volume of the. See here, Spark data is going to be stored. Spark data is going to be stored in the RAMs. See, for example, your RAM. What is your RAM capacity? Assume 64 GB RAM. Your data volume is so and so. Means how many those kind of RAMs, system RAMs are required. Those many you need to configure. That's why if you want to go with Spark, if you want high speed, the infrastructure like RAM also you need to arrange, that much RAM you need to arrange. 10 systems, you have got 10 systems. Each one has got 64 GB RAM. Totally 640 you are going to get. It can accommodate 640 GB. If your data volume is how much, if it is more than that, again you need to increase it further. 20 systems into 64 GB. How much space, how much you are getting? So whether it can accommodate or not. If you're unable to accommodate, you need to increase the more system. In that way. Okay. Any other queries? Yeah, so okay, people yesterday some of the people were requesting, right? Okay, so if you doesn't have knowledge on this Python also, DurgaSoft they were saying, right? They'll be providing with the basic Python videos. Okay, you can just go through that because you will be getting some time of 10 to 2 weeks, right? Because we'll be discussing with the Azure DataBricks before going with the actual coding part, right? Fine. So this is one of the in-demand tool, right? On-demand tool in this market with a huge salary package. You can see if you check with this PYSPARK or this Azure DataBricks, right? Combination, you can see bigger packages. You can see because the main thing in the industry for Azure data engineer, for this data engineer, right? PYSPARK. You can demand the salary for this, especially for PYSPARK developers, right? As you are going to do. In the same way, you need to have some command on this entire PYSPARK. Okay, fine.
Sir,
So yes, yes.
Can I expect this course complete within the time period?
2 months it takes. Maximum, I'll be taking some extra sessions, right? During some weekends also, some bigger sessions. I'll just intimate you about the timings, right? If you're running out of time.
Okay.
Okay, fine. But it's a hands-on batch, right? So generally it's hands-on you can do along with me parallelly, but I'll plan some bigger sessions also on the weekends, Saturdays and Sundays, right? When required. Okay, thank you all for your time. Thank you. Meet you tomorrow same time.
And also one more question I have. Okay.
Yes.
Yeah, I'm attending from the PST hours. Okay. So if you are taking the long sessions on weekends, right, it's hard to attend from here. Okay. How would
No, not like that. Okay, I'll just intimate about the timings. I'll have a discussion with you people, right, about the time before I go.
Okay, sure. Thank you.
Okay, fine. Fine. Okay, meet you tomorrow at 8 o'clock, same time, fine, with the same link.